So hi everyone and welcome back to our YouTube channel Moments with Chemistry. So today, since this is our debut video, we thought of just starting out with A-Level 2020 chemistry paper where we will be discussing the first 10 MCQs. Okay, question number 1. Consider the following discoveries made with regarding to the atomic structure. So the first one is positive rays inside a cathode ray tube. Second one is radioactivity by certain types of nuclei. Then they are asking the two scientists. So this is just a straightforward question from unit 1. Even if you just had read through the theory, you would have got it. So the first one, positive rays were actually discovered by Goldstein and radioactivity was by Becquerel. So first question, your answer will be answer number 5. First question, answer will be answer number 5. Second one, the number of electrons in the manganese atom with atomic number 25 that have quantum numbers L equal to 0 and Ml equal to -1 respectively are. So since manganese is 25, first of all you have to write the electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. So then they are asking for us to identify or satisfy the condition where L equal to 0. So if L equal to 0, you know that it should belong to an s orbital. It should belong to an s orbital. So he can come, yes. Even he can come, still yes. This one is also possible, s. And indeed this one. So to satisfy L equal to 0, we have 4 s orbitals. So 4 s orbitals means the total number of electrons will be how much? 2 into 4, 8. So the total number of electrons for L equal to 0 will be 8. Then Ml equal to -1. Then the other one which we have to consider is Ml -1. Now if Ml should be -1, there are two possibilities. Fine? Possibility number 1 is it should be one of the p orbital. Out of the 3 p orbitals, it should be either one of them. That is one possibility. The other possibility is out of the 5 d orbitals, it can be either one. So now we have two possibilities. Either it should be one of the p or one of the d. So here if you consider this one, 2p6, then according to Aufbau and Hunt and Pauli and everyone, if we have to 2p6, this is 2p6. So if I consider this one as -1, 0 plus 1, so for -1 we will have here 2 electrons from 2p6. Similarly from 3p6 also we are going to get 2 electrons. So we have 2 electrons from 2p6, we have 2 electrons from 3p6. What about 3d5? If I draw the orbit diagram for this, 1, 2, 3, 4, 5. So to satisfy Ml equal to -1, just one of this is enough, no? So here we will have 1 electron. So the total number of electrons that satisfy Ml equal to -1 is 2 plus 2 plus 1. Total is 5. So your answer should be 8 and 5, answer number 3. Question number 2, answer number 3. Question number 3. M is an element which belongs to the second period of the periodic table. So if they say second period, concentrate only on the second period. Your mind should not wander into other periods. Concentrate only on the second period. It forms a covalent molecule MCl3, which has a dipole moment. The group in the periodic table to which M belongs. So MCl3, there are two possibilities. It should be in period 2, and at the same time for MCl3 there are two possibilities. What are the two possibilities? One is BCl3, other one is NCl3, and it should have dipole moment also now. So if you consider BCl3, it's like this. So he will have slight delta negative, he will have the delta positive. So positive to negative this way, positive to negative this way, positive to negative this way. So here total dipole moment equal to 0. But if you consider NCl3, nitrogen has a lone pair. And the most important thing is this is delta positive. When you consider the electronegativity of nitrogen is what? It should be greater than that of chlorine. So then this is delta positive, this is delta negative. So positive to negative, this way. So he will have a resultant dipole moment. So the answer should be concentrating on nitrogen. So it will be period number, it should be period 2, but group number 15. So question number 3, answer will be the fourth one. Next one, the number of unstable Lewis dot dash structure which can be drawn for peroxynitric acid. So good thing these people have given us the most stable Lewis structure. So using this most stable Lewis structure, you should be able to draw the unstable Lewis structure. So before that, first of all, we'll see what are the criteria that qualify a particular Lewis structure to be unstable. Now for all the Lewis structures you draw, you have to choose the unstable one. So how are we going to choose it? Number 1, the more electronegative atom carries a positive charge. For example, oxygen gaining positive. Number 2, two adjacent atoms have the same charge. So there's more repulsion. Number 3, charge separation within the molecule is greater. For example, if we have nitrogen -2 and let's say with oxygen you have another -2, so charge separation within the molecule is great. So we have to minimize the charge separation. So, and luckily these people have even bold the letter unstable. So for this unstable, we can draw actually structures like this. Now look at this. Oxygen, nitrogen, oxygen, oxygen. And the other thing is very important, when you draw any Lewis structure, the total number of pi bonds and the total number of lone pairs should be constant, should be the same. So according to this, we can have only one pi bond within any molecule that we draw. So if I put here, this oxygen will gain a positive charge. And this nitrogen will gain positive charge. So since oxygen is having a positive charge, unstable. Otherwise, if I shift this pi bond to this location, may pi bond I am shifting to this particular location. So if I shift the pi bond to this location, can you see? Here, oxygen is having a positive charge. That itself is bad. On top of that, two adjacent oxygen atoms have similar charges. So therefore, the repulsion is greater. So actually looking at them, you can draw only two stable Lewis structures. Because if you put that two unstable Lewis structures, because if you put the pi bond to this particular location, it will become stable. That's why. So you can draw only two unstable Lewis structures. So fourth one, your question is, for question number 4, your answer will be answer number 2. Next one, they are asking IUPAC nomenclature. Actually that is also a very good question, because all the rules pertaining to nomenclature has been tested in that question. So, first of all, we will consider what are the rules that we have to follow. So, first one, you have to be able to choose the longest carbon chain. The longest carbon chain in your molecule should be chosen. Next one, you have to identify what the functional group of your molecule is. What the functional group of your molecule is. Then you have to identify what are the other side groups that are attached. And then you have to start numbering. So here, this is how, this is going to be a longest carbon chain. No two words for that. Surely this is the longest carbon chain. Because if you go upwards, there is no way as to how I can name CH2OH. If you go upwards. So this is the only possibility. Next one, how am I have to identify my functional group. So if you have properly memorized the precedence list, you know that ketone is higher than alcohol. So ketone should be the highest one. So for that, your answer should end with on. So just looking at that, you can cut off 4 and 5. So your answer should be 1, 2, 3. And then you have to label. If you have to number or label the carbon atoms like this, imagine I am labeling it like this. Then here he gets 3. The keto groups get 3. No issues. But can you look at this? The double bond gets 4. There's a problem in that. Next one, you start from the right side. 1, 2, 3, 4, 5. Here, same 3. Your also keto group gets 3. But the double bond gets 1. The double bond gets 1. Other main important thing is, which many people fail to understand, is this: any double bond, triple bond, they should be awarded the lowest number in the longest carbon chain. So here it's 1. 1 is better than 5 or 4. So you have to name your molecule from the right side. If you name it like that, you will get 1 bromo 5 hydroxy 4 methyl pent 1 in 3O. So your answer should be answer number 3. Fifth question, answer number 3. Okay, so that was just, actually it was a very good question because all parts of organic chemistry were tested in that one. Question number 6. Question number 6 is also very good. They are asking the size of molecules. So you know that when the period increases, the number of shells increase. So if the number of shells increase, the size should eventually increase. So looking at that, S2 minus and Cl minus, they belong to the third period. So since they are in the third period, they should be the highest values. Since they are from the third period, they should be of the higher values. So since all our answers are there, we have to go for another solution. So if you consider S2 minus and Cl minus, both of them have argon configuration, but the number of protons which are concentrated within the nucleus of chlorine is greater than that which is concentrated within the nucleus of sulfur. So therefore the attraction between the nucleus and the outermost electron in Cl minus is greater. In Cl minus is greater. So if the attraction is greater, the size of the molecule will become low. So it's like this. Let's say a new member comes into your family, a newly wedded member comes into your family. All of a sudden, you don't like him. So if you don't like him or her, there will be repulsion. There will be repulsion. Because of repulsion, at a certain moment, the family may try to, what? They will try to diverge from one another. Similarly, that's the same thing. That's going to happen with anions, which we will be seeing. Okay? So from this we know that S2 minus is bigger than Cl minus. S2 minus is greater than Cl minus. Next one, O2 minus F minus also same thing. It's just that their periods are different. So O2 minus F minus. And also you should know that the anions are greater than their neutral atoms. You know why? Now for example, you have 3 electrons. Let's say he gets 1 electron. Here electron-electron repulsion becomes the governing factor. What becomes the governing factor? Between one electron and the other electron, the electron-electron repulsion becomes the governing factor. So because of that, the family tends to diverge. Like you have a newly wedded people, they don't like each other, so then they should diverge from one another. Get it? So then there will be divergence in the molecule. So because of that, the molecule will have to become bigger. So anions are always bigger than their neutral molecules. So looking at that, your answer should be S2 minus Cl minus. Here O2 minus F minus. O2 minus F minus. Then oxygen and fluorine. So this is properly shown in answer number 1. Okay, question number 7, that's just, it was a very easy one. A rigid closed container containing n1 number of moles of an ideal gas at temperature T1 and pressure P1. Temperature T1 and pressure P1. When an additional amount of gas was inserted into the container, the new temperature and pressure were T2, P2. Then they are asking the total number of moles in the new container. So it's just, initially we have P1, T1, N1. That is the initial conditions. The new conditions are P2, T2, N2. Since this is a rigid container, volume is not going to change. So PV equal to nRT. First of all, remove all the unwanted constants. V is a constant, I remove it. R is a constant, anyways, no 8.314, that is also out. So P1 over N1 T1 equal to P2 over N2 T2. But question is asking you total number of moles in the gas now in the container. So N2 value only you have to subject. So if you subject N2 you have to take it to this side. Then if you do the cross multiplication, P2 N1 T1 divided by P1 T2. So this is given in answer number 2. Seventh question, answer number 2. Okay, question number 8. The total number of electrons exchanged in the reaction of oxidation of ethanol to acetic acid using potassium dichromate in the acidic medium, or using acidic potassium dichromate solution X. Okay. So for any reaction to happen, we should have an oxidation and a reduction. So reduction will be Cr2O72 minus plus 14H plus 6 electrons giving you 2Cr3 plus 7H2O. And your oxidation will be CH3 CH2OH should give you CH3 COOH. So number of carbons 2, this also 2. Very good. Number of oxygens. Here we have 2 oxygens, but here 1 oxygen. So we have to add 1 more oxygen. That will give you 1 water molecule here. Then number of hydrogen. 3, 5, 6, 8. But here we have only 4. We have to add another 4 more hydrogen. How to add them? Acidic medium. We have H plus. So for that, plus 4H plus. So to balance the charge, 4 electrons. So here 4 electrons have been released through oxidation and 6 electrons have been gained during reduction. So for the reaction to take place, the number of electrons that are released and the number of electrons that are gained will be equal. So you have to find the common factor between 6 and 4. Common factor between 6 and 4. So this is just roll over mathematics. 6 and 4 common factor is what? 12. So your answer should be 12 electrons, answer number 4. So your answer will be 12 electrons, answer number 4 for question number 8. The next question, which compound of following can undergo aldol condensation when reacted with aqueous NaOH? Okay, so to undergo this aldol condensation or self-condensation reaction with aqueous NaOH, preliminarily 2 conditions should be satisfied. Number 1, the given organic compound should be either ketone or aldehyde. Number 2, the carbon that is adjacently attached to the carbonyl carbon, that is this carbon, should bear hydrogen. If so, this carbon is known as the alpha carbon, while this hydrogen is known as the alpha hydrogen. Okay, so these 2 should be satisfied. So if you look at the first answer, carboxylic acid, throw into the bin. Second one, ester, don't even think about it. Third one, ester, same thing, throw it into the bin. Look at the fourth one. Fourth one is aldehyde. And that aldehyde is like this, CH3, CH2, COH. Here we have acidic hydrogen, so it will react. But if you look at the fifth one, CH3, CCH3, CH3, COH. The carbon adjacently bonded to the carbonyl carbon doesn't have free hydrogen to react, because we need to get the hydrogen, no? Since this is a nucleophilic addition reaction, and alpha hydrogen is a must, like this. So your answer for question number 9 will be the fourth one. Question number 10. AX solid, A2Y solid, AZ solid are sparingly soluble salt. The most important word there is sparingly soluble salt. Means we can apply our equilibrium laws and the equilibrium, whatever the necessary expressions we can derive. Okay, and AZ solid are sparingly soluble salts in water having KSP values. Numerical values for KSP is also given, respectively at 25. Which of the following shows the order of the 3 saturated solutions of this salt in decreasing concentration of cation A plus at 25? Okay. So for the first one, for AX solid, if I write, AX solid giving you A plus aqueous plus X minus aqueous. So if I consider A plus concentration to be X, X minus concentration will also be X. So KSP equal to A plus aqueous concentration into X minus aqueous concentration, that is equal to X squared. So here X squared equal to, look at this, 16 into 10 to the power minus 9. So instead of writing 1.6 into 10 to the power minus 9. So instead of writing 1.6 into 10 to the power minus 9, for easy mathematical calculations, I am going to modify it, writing 16 into 10 to the power minus 10. Same thing now. That is equal to 16 into 10 to the power minus 10. So X equal to 4 into 10 to the power minus 5. That is equal to the A plus aqueous concentration coming from who? From AX. From A to Y solid dissociates to give you A plus aqueous plus Y2 minus aqueous. So if you balance the equation, here we'll get 2A. So if this is X, this is X by 2. Or that is just normal stoichiometry. You need 3. This one. But to write all this, you should have a sound knowledge on your equilibrium. Huh? Because first 10 questions, no. Speed also matters. Okay, so X. So KSP equal to A plus aqueous concentration squared into Y2 minus aqueous concentration. That is equal to X squared into X by 2. That is equal to X cube by 2. Value is given. Look at that. 3.2 10 to the power minus 11. 3.2 now. I will make it 32. So if I make it 32, how will it be? 32 into 10 to the power minus 12. 32 into 10 to the power minus 12 into, this 2 will come here now. 2 equal to X cube. So X cube equal to 64 into 10 to the power minus 12. X cube equal to 64 into 10 to the power minus 12. So here what is X? You just have to take the third root of this. You have to take the third root of this. What is the third root of this? 4. 4 into 4, 16. 16 into 4, 64. Into 10 to the power minus 3. Okay, that is A plus aqueous concentration coming from whom? A to Y. Okay, so that's 4 into 10 to the power minus 3. This is if I consider X2. X1 is 4 into 10 to the power minus 5. I come to the last one, that is AZ. So for AZ solid giving you A plus aqueous concentration plus Z minus aqueous concentration. So if this is X, this is also X. So KSP equal to A plus aqueous concentration into Z minus aqueous concentration, which is equal to X squared. Given 9 into 10 to the power minus 12, very easy one. 9 into 10 to the power minus 12 equal to X squared, X3 square, if I consider this to be X3. So X3 equal to 3 into 10 to the power minus 6. So this is 10 to the power minus 6, 10 to the power minus 3, 10 to the power minus 5. So which is the highest one? X2. Why? 10 to the power minus 3, no? Next one, 10 to the power minus 5, X1. Next one, X3. So X2 is for A to Y, then it will come for AX, finally it will come for AZ. Okay, so for question number 10, your answer should be answer number 2. So that ends our debut video. Thank you so much for watching. If you have any comments, any suggestions as to how we can improve ourselves so that we can reach a greater arena of audience, please do include your valuable suggestions and comments in the comment box below. Hey everyone, I think that particular video had added some amount of advantage to your pinnacle of success. Chemistry will indeed become one of your most favorite subjects at the end of what we take as a journey. So don't forget to like, share and subscribe this particular channel with those whom you like. And wait, whether your comments are advantages or disadvantages, please do put them down in the chat box, because everything amounts to us. So thank you and have a nice day.